Now looking at piecewise defined functions. So we have a function defined by two parts. Here is the square root of x, and then which is for any value for x greater than or equal to 0. And here is 1 over x if x is less than 0. All right, let's first answer the two questions, A and B. We have to find where the value, so -2, which one does it apply to? Does it apply to the first formula for f of x or the second? So remember, we can't plug it into both because then it wouldn't be a function anymore. We get two different answers, and like we said, we can't for it to be a function. When you plug in one x, it must come back as one y, right? You can't get multiple values after you plug it in. So this means it can only be appropriate for one of these two formulas for f of x. So looking at the if statements is going to tell us which one it belongs to. So I always kind of look at that inequality. So setting it up, plugging basically this value, this -2, into each of the inequalities, and then finding if it's true or false. So if -2, that's what we're plugging in, is greater than or equal to 0, if that's true, then that's the formula for it. But -2 is not greater or equal to 0, so this gives me a false statement. When I look at the second if statement, -2 is less than 0, this is true. So the minute I find one of them being true for my value that I plug in, that's the formula I'm going to use for it. So that means f of -2 is equal to 1 over -2, which is -1/2. Same thing for 9. So again, we're going to check the if statements. So plugging it into the first if statement, so 9 is greater than or equal to 0. Well, this is true. And the minute you find that first one that's true, there should be no other place that this would be true for. So we immediately can go ahead and go, okay, we have our formula, which is the square root. Oops, I'm going to plug in 9. The square root of 9. So which gives us 3. Okay. When we go to sketch the graph, I like to remember what each of these actually looks like, going back to our toolkit functions and remembering the shapes of each. So doing the first one here, I do this one in green. Remember the shape of the square root function. Starts at 0, 0, and then slowly climbs upward. Okay, just like that. The shape for the reciprocal function. So remember, we have basically these two asymptotes here and here, and then the graph actually goes like that. Oh, that looks weird. There we go. There we go. Okay, so those are our basic shapes. That's it defined on its full domain as well. Now remember, these restrictions now will tell us that we're only going to have part of the function. Okay, so for the first one, we're going to be looking at from greater than or equal to 0. So we remember those key points for the square root function. We had 0, 0, which is greater than or equal to 0, 1, 1, which is again greater than or equal to 0, and 4, 2, 4 being greater than 0. So we have those key points on this side. And it's saying basically we have the arrow continuing it because we have no endpoint. It just says for x greater than or equal to 0, so it continues on that way. So we always want to label some of these points as well. So we have 0, 0, 1, 1, and 4, 2. For the other side of this, when I have 1 over x, I see that, again, I'm going to be looking at only on the left side of the y-axis, right? So because the y-axis is where x is equal to 0. So I'm looking only on the left side because I'm thinking of less than. Remember, if you plug in 0, you would get something undefined. And that's the reason we have an asymptote on the original. Okay, we're not going to put that in here because the function's actually defined for 0 for the first half where it actually belongs. So it's defined at 0, 0. But when we have, like, say, -1, when I go to plug that in, -1 comes back as -1. That was one of our key points. And we then draw the graph as this curve that goes along towards the axes. And that's how we sketch the graph.